In this vector, we're going to look at adding two vectors. In this video, we're going to look at adding two vectors. So let's imagine that we have two forces. Force number one is maybe 10 newtons and has an angle of 50 degrees. And force 2 is maybe 8 newtons. And let's go ahead and use 3 significant digits for these. So this will be 8.00 newtons, and this will be 10.0 newtons. And 50.0 degrees, and this one can have an angle of 30.0 degrees. And we'd like to add those two forces together, and I want to be clear that the answer is not 18 newtons. Because the vectors point in two different directions, we cannot just add their magnitudes. So if we have two vectors like this, what it means to add them together graphically is we take the first vector, that's my 10 newtons, with my angle of 50 degrees, and we then start the second vector at the end of the first vector, and so this is going to be my 8 newtons with my angle of 30 degrees. So then the answer to the addition problem is a vector that starts at the beginning of the first vector and ends at the end of the second vector. So this would be f1 plus f2 because we put f1 first and then we put f2 second. You might be curious, do we get the same thing when we do f2 plus f1? And yes, we would. If we start at the beginning with force 2 and then we add to that force 1, we would end up at the exact same place. So f1 plus f2 is the same as f2 plus f1. That's good. We want it to be that way. All right, so mathematically, how do we do this? And there are two ways to do it mathematically. The first one is to use the law of cosines. The law of cosines is effectively a more complicated version of the Pythagorean theorem. Like if we call this A, if we call this A and we call this B and we call this C, if this was a right triangle, C squared would equal A squared plus B squared. It's not a right triangle, so there's a different rule called the law of cosines, and that works, and you can do that. If you want to do that for your homework, that's fine, but that's not what I'm going to teach us. Instead, I'm going to teach us the component method. So in the component method, what I want you to see in this picture is force 1 has a y component and an x component. So this would be f1x and f1y. Okay? And force 2 also has an x component, f2x and f2y. And if we look at the answer, the blue vector that is the result of adding these two forces, it also has an x component and a y component. And what we can see from this picture is that the x component of our answer is going to equal the x component of the first force plus the x component of the second force. And the y component of our answer is going to equal the y component of the first force plus the y component of the second force. So if I want to add these two vectors together, the first step is to find their components. All right, so this is just going to involve some trig. So this angle is 50 degrees. So we have 10 times the cosine of 50 degrees to get the base of the triangle. So that's 6.4279. Notice I'm keeping a few extra significant digits in the middle of the problem, and we'll round off to the correct number of digits when we're done. And then to find the height of the triangle, it's 10 times the sine of 50 degrees, and that gives me 7.6604. For the other triangle, I have 8 times the cosine of 30 degrees to get the base of the triangle, so that's 6.9282. And to get the height of the triangle, that's going to be 8 times the sine of 30 degrees, which gives me 4. Okay. So then, to find the x component of our answer, we need to add the two x components. 6.4279 plus 6.9282 gives me 13.3561. And to find the y component, we need to add the y components. So I get 7.6604 plus 4.0000 gives me 11.6604 newtons. Okay, that's supposed to say F sub y. Okay, so then I can write my final answer, and I can say, okay, the final answer for this force is 13.4 I hat plus 11.7 j hat newtons. And that would be the answer I get when I add those two vectors. And this is in Cartesian coordinates, rectangular coordinates. But it might be useful also to get this in polar coordinates. So to find the polar coordinates, I'm going to draw the triangle. Because anytime I try to convert between polar and rectangular coordinates, I always draw the triangle. So this triangle has 13.3561 on the base and 11.6604 on the height. And so I can find two things. I can find the angle, which is the inverse tangent of opposite over adjacent. So 11.604 divided by 13.3561 gives me an angle of basically 41 degrees. Okay, and then I can also find the hypotenuse by using the Pythagorean theorem, the square root of 13.3561 squared plus 11.6604 squared equals 17.7. So this force is also equal to 17.7 newtons at an angle of 41 degrees. This is supposed to be an angle sign, an angle of 41 degrees. 17.7. Sometimes it's hard to write on an iPad, sorry. All right, so that's how we add vectors. And I guess that'll be it for this video.